Hello everyone, this is Madhu Sirikonda, Assistant Professor, Mechanical Engineering Department, belongs to St. Peter's Engineering College, Mesamaguda and Kolkata. The subject that I am handling for final year is Instrumentation and Control System. In short form, it is ICS, Instrumentation and Control Systems. As per our JNTU-H curriculum, we are having 5 units. The first unit, it explains about the simple definitions and principles of measurement. Principles of measurement. The second unit, measurement of displacement, temperature and pressure. The second unit. Third unit deals with the measurement of level, flow, speed, acceleration and vibrations. Fourth unit, and similar, the fourth unit is stress strain measurements, humidity, force, torque and power. Here we are going to measure force, torque and power with the help of instruments. In previous years, you might have calculated the forces, torque, force into radius, power, the rate of doing work. By using the formulas, we have calculated these things, but we have instruments to find out what is the magnitude of the force, torque, and power. Like this, humidity. The moisture content that is present in atmospheric air is humidity. So theoretically, we can calculate, we are having the formulas. But we have instruments to find out what is the humidity present in the atmosphere. And that we deal with, that is present in fourth unit. And the last unit is elements of control system. Elements of control system. It is all the 4 units deal with instrumentation and that is measurements. Whereas this fifth unit is dealing with the control system. How to control a process. For example, we are having our ACs, air conditioners. We are having air conditioners. And I will set the limit of temperature to, say, 20 degrees. 20 degrees Celsius. Then what happens? If the temperature is increasing, about to increase to 20 degrees, the sensors will give information to the chillers to increase the effect of refrigeration, to maintain that less temperature, 20 degrees. Or if it is decreasing less than 20 degrees, the same thing will happen because of the feedback systems. The feedback system, it will measure the output and it will give feedback to the input such that the small changes will take place in the process and gives the required result, set result, that is 20 degrees Celsius. So that we will see in elements of control system, that is the 15. So overall we are having 5 units. The 4 units there were the measurements of various physical quantities. It can be a displacement, say length, the temperature, pressure, or levels, flow meters, etc. You might have heard the devices in previous years or semesters, but now we are going to see the functioning of these instruments. Let us continue with the instrumentation. What do you mean by instrumentation? It is the branch of engineering science which deals with measurements, measuring devices, associated with the measuring techniques. It is a branch of engineering science developed measurements, measuring devices, and the problems associated with measuring techniques. Now, what do you mean by measurement? What is measurement? Before we see the definition, we go through an example. We are having 2 points. I want to find out the distance between these two. Distance between these. Say, I use a meter scale or a centimeter scale and I will find out this distance and say, this is 20 centimeters or 0.2 meters. How we are going to measure this? By using an instrument. By using an instrument. And we are comparing the distance between these two with that instrument, so-called tape, a measuring tape, meter tape. It can be in meters, inches, or feet. One more example. We will go to market. We will try to find out, we'll try to get milk. What we will ask? We ask for, give 1 liter milk, 2 liter milk, say 1 liter or 2 liter. This liter is the measurement. Here we cannot use meters. Here the physical quantity is different. One more example. Eggs. We cannot buy eggs in kgs. We cannot buy eggs in liters. Eggs are born in terms of dozens. Say 1 dozen, 12 eggs. It is a number. It is one more method of measuring a quantity. So there are different types of measuring quantities, measuring methods. That is what we will go through in coming classes. No. So something we are doing here. This much distance we are comparing with the so-called meters, and this much volume we are comparing it with 1 liter, or this much, if it is a bigger one, 2 liters. For 12 eggs, we are calling it as 1 dozen. But something is there, which is linking all these things. That is a standard. We call it as a standard. You have this much physical quantity here is length. So this length is compared with a standard. Length is compared with a standard. What is a standard? Meter tape. Example, we are using a meter tape because it is a standard. So length is compared with the standard meter tape, and we are saying that it is 0.2 meters or 20 centimeters. Similarly, we are having some vessels of 1 liter, 2 liter. We have a measurement there. Within that, it can be a cylindrical shape or it can be conical. If you repeated that, it is 1 liter. So we always compare the given physical quantity, the given quantity, unknown value with a known standard, say it can be a meter tape, or it can be a volume measuring flask, or it can be a number, so called 1 dozen, 2 dozen, etc. Right? No. So, how that will see? I don't know, small graph, diagram. So, in general, the measurement goes like this. You are having a unknown, a physical quantity. It can be physical quantity in the sense it can be length, mass, or the parameters like force, all the things that we have seen in the units, different units, force, torque, power. That is a quantity now. Now here it is an unknown value. Suppose if it is an unknown quantity, unknown quantity, or we can also call it as a measurand. We call it as measurand, whose value is unknown or whose value is to be known, is known as measurand. This measurand is compared here. Here compared with what? With a standard. With a standard, we compare our unknown quantity or measure it, then finally we give a result. Result in the sense, that's what, so many meters, 1 liter, that's it, like that. So that's a result. So this result can be a number. Result can be a number, and we just compare this quantity, the unknown quantity, with the standard. Here we do comparison and we will give the result. Now, what is a measurement? Measurement and unknown quantity, which is to be measured, which is to be measured. For example, length, mass, pressure, temperature, etc. The unknown quantity which is to be measured can be length, mass, pressure, temperature, etc. It can be anything which is to be measured. We don't know, right now we don't know what is the temperature outside, what is the pressure outside. Because there's a standard one, of course, when we go through the mobile. Globally, the temperature pressures are 1 atmospheric pressure, temperature is around 22 to 30 is around. But it will vary. But exact value to be known means we should compare this environment because now it is a measurement. Now this atmosphere is a measurement. Now if I bring a thermometer, ordinary thermometer, that will give us the temperature. That will give us the temperature. Now, what's the standard? It is a known quantity which is used to compare the is used to compare the measure. Now, comparison takes place here, and we will produce the result. The observer will produce the result. It can be a number, any other unit. If it is force, so many newtons. Power, so many watts, kilowatts. Depending upon its unit, we give the result in its suitable form. Now, we will continue with applications. Here we continue with applications of measuring system. In applications of measuring system, we are having three different areas. We are not using the measuring. We are not telling that measuring system is used only in one area like industries or pharmaceutical industries or any other areas. They are present everywhere. Everywhere it is present. To produce any product, measurement is required. So we are not specifying the areas where it is happening, but how the things are happening. What are the purposes? How they are serving us. So that is what is discussed, and we call it as applications of measuring systems. Monitoring of processes and operations. Any operation is taking place. How it is taking place. What is happening there? What is the value present there? Next step. Control processes and operations. The second one is control processes and operations. The third one is experimental engineering analysis. And engineering analysis is done theoretically and practically. It is experimental. In theoretical methods, we may not use the measuring systems, but during calibrations we can use. The instruments can be exactly implemented and used in experimental methods. After comparing the results obtained during an experimental setup, we can do modifications. If we don't get the relevant results, we can do modifications, simplifications through theoretical calculations, and that can be implemented into the experimental setups. So there are three. Now, coming to the first one, monitoring of processes and operations. Example, simple thermometer. Now, monitoring the process is saying some process is taking place in a container. Now, I want to find out what is happening in the container. What happened to a property called temperature in it? I use a thermometer, or it is not always a mercury in glass thermometer. There are wide varieties of thermometers. If I want to find the temperature of the sun, I cannot use ordinary thermometer and find the temperature of the sun. There are different varieties of thermometers. Now, so what I will do to find out the temperature, I will use a ordinary thermometer for right now. I am using it. I just hold it in that setup, for a device, such that I will find out the temperature. So what is happening to that process? There's a thermometer which is used to find out the temperature. Pressure gauge is used to find the pressure. And water, gas, electric meters. Water meter, how much water we are using. In our apartments, we will be having those meters, water meter, gas meter, electric meters, in general, electric meters. Depending upon the number of units it runs, you will be charged. So, these are the instruments used only for monitoring purpose. Is the first type of application. Second type of application is control of processes and operations. How it will control a process. In what way it will control. The name itself says instrumentation and control system. We didn't discuss about what is the control system. Now, this is what control system. Controlling a process is taking place here. You have a set up a device, some process is taking place in it. We are giving some input and it has to produce an output. But to what extent the output is to be produced, or what is the desired output. That value is set. If I want to set the value, yes, for example, home heating and refrigeration systems. I want fixed. I have fixed the temperature. But by the continuous input to a process, we cannot simply stop the output at the desired one. This input must be cut off or it must be raised to reach the required desired output. How it will happen? There comes control system. Here, this output. So how it will happen? Because this is a feedback system. So how this will happen? You will get an output, and from the output, the measuring instrument it will consume some part of the output, and it will read what is the output, and that information will be given to a controller. If the value, okay, the controller, and from the controller to a final control element, this will set up either to increase the input quantity or to decrease the input quantity. Suppose if the output is greater than the desired one, so what this controller will give the information, the final control element will decrease this input value. If this output value is less than, if this output value is less than the actual desired value, then again this controller will increase the input quantities such that always the desired output is balanced, it is maintained. Plus or not plus or minus, it can be an exact value of desired output. And the final one is the third type of application is experimental engineering analysis. This we have seen this before. Theoretical method, experimental method. If the experimentally we are not getting the exact results according to our theoretical calculations, we can do modifications in the experimental setup, and further we can go for the other changes, even if repairs are there or modification of the instrument or replacement of the parts that can be done. And we will continue the session in the next lecture. In the next lecture, we will see the methods of measurement. There are different methods: direct method, indirect method, primary measuring method, secondary, tertiary methods. So those methods we will discuss in the next lecture. Keep on watching.